Hi, welcome to one and all. Next, we will be discussing the evaluation of minus 1 over p and 2 over p. The Legendre symbols minus 1 over p and Legendre symbol 2 over p. We have the theorem for every odd primes p, we have minus 1 over p. Legendre symbol 1 over p is equal to minus 1 raised to p minus 1 by 2, which is equal to 1 if p is congruent to 1 mode 4 and minus 1 if p is congruent to 3 mode 4. This is what we have to prove by Euler's. So earlier we have already proved a result, that is the Euler's criterion. We have already proved that, which is nothing but n over p. The relation to simple n over p is raised to p minus 1 by 2 mod p, where p is an odd prime. So here we will be proving that for minus 1 and for 2. So here we know that by Euler's criterion we have n over p. The relation to symbol n over p is congruent to n raised to p minus 1 by 2 mod p. So clearly putting n equal to minus 1, we can will get minus 1 over p. Relation to symbol minus 1 over p is congruent to minus 1 raised to p minus 1 by 2 mod p. Now what we have to prove is, we have to prove that these two are equal. That is, these two are equal. Here it is not congruent, it is equal. So now we want to show that these two are equal. For that, we know that minus 1 over p can take two values, that is minus n over p can have the values plus or minus 1, that is minus 1 or plus 1, that we all don't know because p is an odd prime and p does not divide n. So clearly this minus 1 over p is either minus 1 or plus 1 by our definition of Legendre symbol. So here we will also we know that minus 1 raised to p minus 1 by 2 will also take values plus 1 or minus 1. Now what we have to prove is that both these quantities takes the same values at every time. So this is what we have to prove. So we have to prove that minus 1 over p, relation to symbol minus 1 over p and minus 1 raised to p minus 1 by 2 takes the same value. For that we consider this four cases, that is we will take different values and see what happens. See, if minus 1 over p is equal to 1 and minus 1 raised to p minus 1 by 2 is equal to minus 1, then we can see that this is equation A. So by this equation we can see that 1 is congruent to minus 1 mod p, which is 2 is congruent to 0 mod p. This means that p divides 2, or 2 is divisible by p. 2 is divisible by p, but since p is greater than 2, which is this thing is impossible. So this we cannot take, that is plus 1 and minus 1 we cannot take. So next we take minus 1 over p as 1 and minus 1 raised to p minus 1 by 2 as plus 1. So both having plus 1 value. Then in this case we will get 1 is congruent to 1 mod p, which is 0 is congruent to 0 mod p we will get. So which is possible because 0 is divisible. So next we will take minus 1 over p is minus 1 and minus 1 raised to p minus 1 by 2 is minus 1. That is both same values. In this case also we will get a 0 equal to 0 mod, which is also possible. But again if we take minus 1 raised to minus 1 over p is minus 1 and minus 1 raised to p minus 1 by 2 is plus 1, then this is not possible. So it will be minus 2, which is not divisible by 2. So p does not divide minus 2, which is not possible. So in these four cases we can see that whenever this minus 1 over p and minus 1 raised to p minus 1 by 2 takes the same values, the situation is possible. So in that case we can see that minus 1 and minus 1 raised to p minus 1 have the same value. The congruence is satisfied only when these two have the same values. So first we have proved that minus 1 over p is same as minus 1 raised to p minus 1 by 2. Next we have to prove the other part, that is minus 1 raised to p minus 1 by 2 is equal to 1 if p is congruent to 1 mod 4 and minus 1 if p is congruent to 3 mod 4. This can be done in two ways. Let us take the first case. The way I am only saying about the one way. The other way you can prove as, let us take minus 1 raised to p minus 1 by 2 as 1. So in that case you can see that this is 1 only when this part is an even number. So this should be taken as an even number. So I am taking it as 2k for some k. It means that p minus 1, this 2 is taken to this side. So p minus 1 is equal to 4k. That implies p is congruent to 1 mod 4. So this This is clear. Now if you take this as odd, p minus 1 raised to p minus 1 by 2 is minus 1, then it means that this is odd. That is p minus 1 by 2 is equal to 2k plus 1 for some integer k. That is p minus 1 is equal to 4k plus 2, which implies p is equal to 3 mod 4. And in the other way also you can do this, because if you take p is equal to 1 mod 4, then you can take p minus 1 is divisible by 4, so p minus 1 can be taken as 4k, and that means p minus 1 by 2 is some 2k, which means that which is an even number, so that part is an even number, so the value of minus 1 raised to p minus 1 by 2 will be 1. In that way also you can prove, in the other way around. So this way you can prove this result. Next, quickly we will see the next theorem. For every odd prime p, we have 2 over p is minus 1 raised to p square minus 1 by 8, which is equal to 1 if p is equal to plus or minus 1 mod 8, and minus 1 if p is equal to plus or minus 3 mod 8. So this is somewhat similar, but with some difference. Let us see what is the difference between these proof. As in the previous case, we will just other than the previous case, what we will do is, here we will consider p minus 1 by 2 congruence. Let us consider the p minus 1 by 2 congruence. That is, this can be taken because of the quadratic residues. If you consider the quadratic, there will be p minus 1 by 2 quadratic residues for an odd prime p. So we can take this R congruence. That is, p minus 1 is congruent to 1 times minus 1 raised to 1 mod p. 2 is congruent to 2 times minus 1 raised to 2 mod p. P minus 3 is congruent to 3 times minus 1 raised to 3 mod p, like that. So you take an example of 11 and see what is there. We have already given the example of 11. You simply see that example and compare these results. You will get these results. Okay. So now I'm not going to that. Anyhow, we have some R congruence, where R is either p minus 1 by 2 or p minus 1 by 2. Multiplying these together, what we can get. So see, you have to simply assume this congruence. So only an assumption. Why we are taking is just we will see in the later steps. Multiplying these together, and note that each of integers on the left is an even number. See clearly here you can see that here you can take up to either p minus 1 by 2 or the other part, that is p minus 1 by 2 part. So if you multiply these all these terms, what you can see is this is 2 times 4 times etc, and this remaining part will be up to p minus 1. So this total you will be getting p minus 1. So simply you multiply this. If you take from p minus 1 by 2 to simply p minus 1, you will get this number. And this is simply multiplying this. R is p minus, if you take this p minus 1 by 2, then p minus 1 by 2 minus 1, like that you can take up to p minus 1, and you then take the common factor as 2, and you take you divide it, you will get only even numbers, so 2 4 6 etc, p minus 1, that you will get here. And when here if you multiply, this is clearly that 1 2 3 4 etc p minus 1 by 2, so it is p minus 1 by 2 factorial, and this one is minus 1 raised to how much, 1 plus 2 plus 3 plus etc p minus 1 by 2. So this is here mod p, so it is here. Now this if you take a 2 outside, 2 raised to p minus 1 by 2 outside from here, what you will get, the remaining part will be, they see here there are p minus 1 by 2 terms here total. So here if you take this p minus 1 by 2 terms 2 outside, what you will get is 2 raised to p minus 1 by 2, and the remaining part will be a p minus 1 by 2 factorial, because you will get 1 2 3 etc p minus 1 by 2, because you are taking a 2 outside. So 2 raised to p minus 1 by 2 times p minus 1 by 2. So that is here, which is p minus 1 by 2 factorial, and here we have not done anything. Simply we have added this. This is something like an AP with the n first n natural numbers, like that. So it is, there are p minus 1 by 2 terms, so it will be p minus, it is n times n here instead of n you have n minus 1, so it is n times n minus 1, like that. Here it will be p minus 1 times p minus 1 times p plus 1, like that. So it will be p square minus 1 p minus 1 into p plus 1. So that you will be getting. So p square minus 1 by 8 by 2 is by 4 is there. So it is total, it is 8. So p square minus 1 by 8 you will get if you sum these things. Okay. So now if you cancel this p minus 1 by 2, you can cancel it because this is not 0. So sorry, here it is p minus 1 by 2, not p1 by 2. It's p minus 1 by 2, that is this term. You can cancel, this is not divisible by p, so you can cancel these two factorial terms. So p minus 1 by 2 is p minus 1 by 2 factorial is divisible by p, not divisible by p, so you can cancel these two. So after cancellation you will get 2 raised to p minus 1 by 2 is counted to minus 1 raised to p square minus 1 by 8 mod p. Now what we have to prove is that we have to prove this congruence is equal. So for that, as in the previous case, what we are going to do is minus we want to prove that this two are equal. For that, we already know that this before that, you see here 2 raised to p minus 1 by 2 is constant to 2 over p by Euler's criterion, that we already studied. So this is by Euler's criterion, you can see this is 2 over p. So now you have to prove that 2 over p and minus 1 raised to p square minus 1 by 8 have the same value. For that, we know minus 1 raised to p square minus 8 takes values 1 or minus 1, and we have to show that this 2 over p and this both takes the same value. For that, you will take the 4 cases as in the previous form, and you can see in all cases when both values are same, this is possible, and if both values are different, this is not possible. So this is we can see that only in the case when both are same value, which is possible. So we will get the congruence, and we will see that 2 over p is equal to minus 1 raised to p square minus 1 by 8. Now we have to show that this part, that is minus 1 raised to p square minus 1 by 8 is 1 if p is equal to plus or minus 1 in mod 8, p is equal to plus or minus 3 mod 8. So for that, we will take this first this part. If p is plus or minus mod 8, since p is odd, we can take p is equal to 80 plus or minus 1 because of this. So we will get p square equal to 64 t square plus, we are simply squaring and taking this p1 out on this side, and then dividing by 8, you will get end up with the 8 t square plus or minus 2t, which is an even number. So this part will be clearly an even number. If this is even, then this is even. If this is like this, then this is even number. So here you will get the value as 1. Likewise, like that, if you take this is p is constant to plus or minus 3 mod 8, you can take p equal to 8t plus or minus 3. And similarly, if you proceed, you will get this as an odd number because this and this is even, so plus 1 is odd. So clearly in this case also, you will get minus 1 raised to p square minus 1 by 8 is minus 1 because it is odd. So in both cases, we have proved this, and this completes the proof. And Euler criterion gives a straightforward method for computing n over p, but here the next we have to find a calculation because for large values this Euler's criterion will be difficult. So in that case, we have to find this different value. We have to find a different method to find this which is not a large value. So for in that case also, we have to do. So in the next we will be going to do this. I hope you have understood concepts clearly. If you have any doubt, you can mail me or message me. Thank you for your patient listening.